Hi everyone, welcome to this lecture. So in this lecture, we are going to solve our project 4 on KNN. So here I am in my KNN folder and this is my project 4. So click on this file so that we can open it in our Google Colab environment. So this is my project 4 in Google Colab. And in order to solve the project 4, I need NumPy, I need pandas. So I am importing NumPy as NP, pandas as PD. I need matplotlib. And similarly, I need k neighbors classifier. So I will import it from sklearn.neighbors. I also need train test split function. So I am importing it from sklearn.model_selection. Let's click on this cell so that I can import all the necessary libraries. Now, for this particular project, I am going to use the Titanic dataset. We have already seen this dataset in the logistic regression section. So here we are again going to apply KNN classifier on this dataset. So this dataset is present inside my KNN folder. And we know that in order to read the dataset from a folder, we need to mount the drive and we need to set the path. So the next step is to mount the drive. So we will mount the drive from here and we will click that we have to mount the drive. So Google will ask us for the permission. So we have to permit Google and now we can see that the drive is being mounted. And after this, we will set a path in order to read the dataset from the folder. So drive has been mounted. Let's refresh it from here. And here we are at our drive. So click on the drive. So inside drive, I have my drive. Inside my drive, I have a course material folder. And then inside the course material folder, I have supervised machine learning. Inside supervised machine learning, I have the folder KNN. And inside KNN, I have this dataset Titanic_train.csv. So this is present inside this folder. So I have to copy the path of this folder. So I will copy the path and I will paste the path here so that the path should be set and I will be able to read the data. Now the drive has been mounted, the path has been set. It's time to import the data. Now the data has been imported and we can see the shape of the data that it has 891 samples and it has 12 column. Let's see the first 5 sample. So we can see that this is our Titanic dataset and we have seen this dataset before in the logistic regression section. So let's discuss this dataset again. So here we have quite a few number of features or column. We have passenger ID, we have survived. Now this survived column will be used as a label. It has two values, 0 and 1. 0 means the person died in the Titanic accident and 1 means survived. This is the passenger class. Okay, this is the name of the person, the sex of the person, age of the person, how many siblings the person have. And this is part that is the information about the parents and children which are touring with the passenger. This is the ticket. This is the fare. This is the cabin number. And this is embark. Embark is the place from which, like we can see here, embark implies where the traveler mounted from. There are 3 possible values of embark for this dataset, that is Southampton, Cherbourg, and Queenstown. And similarly, these are the information about the siblings or spouse. This is SIB-SB, that is the information about the sibling of or spouse of a person on board. And part is the feature contain the number of parents or children each passenger was touring with. Now, there are quite a few number of features here. And we can see that we have categorical features as well. That is, sex is the categorical feature. Then we have embarked as a categorical feature. We have the features like age, which are in the number in the form of float. We have a passenger class in the form of integer. So we have quite a few number of features in this data set. Okay, now what to do with this data set? The first step here is check the number of passengers died. So survived is our label. This is our target value. So we have to check how many of the passengers died and how many of the passengers survived. So here I am reading the survived column of the dataset train survived dot value count. Let's run this cell and we can see that 549 of the passenger died and 342 survived. For survived, the label 1 is assigned, and for those passengers who died, the label assigned is 0. The 60% of the passengers died. Now it's time to treat with the features. Now there are quite a few features which are irrelevant features like passenger ID, name, ticket, and cabin. So they are irrelevant features because they are not have influence on the labels, that is on the survived. That is, if the name of a person is something, it has no relation with the survived. Similarly, the passenger ID, the ticket number, the cabin. So these are the irrelevant features. So we have to remove this column in order to move further. So these are the columns. That's why I am dropping these from my data train.drop. And since they are column, that's why axis is equals to 1. In place is equals to true means I want the permanent change. Okay, let's run this cell. And now we can see that we have removed the passenger ID column, name, ticket, and cabin. Now it's time to check for the null values. So the data is train.isnull.any. Is there any null value? Let's run this cell. And we can see that there are two columns or two features where there are null values. The feature is age and the other feature is embark. So the difference is that age is a feature which are in the form of numerical values in the number, but embarked is a feature which is in the form of categorical data. Okay, so we will deal them separately. So how to deal the null values which are present in the column age. So what we are going to do, we are replacing the null value in the age with the mean value of the age. So we are calculating the mean value of the column age, and we are going to fill the null value in the column age with the mean value of the column, and we want to make it a permanent change. So here we are done with the column age. Let's check the null values again. And now we can see that there is no null value in the column age. So student, in the section of data pre-processing, we have learned already how to deal with the missing values, the null values, and the categorical features. So here we are using the same strategy. That is, we are calculating the mean of the column age and replacing the null value in the column with the help of this mean value. Okay. Now it's time to deal with the embark. Embark is the categorical feature. So what we have decided, since we have quite a few number of samples in a data set, that is 891. So we have decided to drop those rows of a data set where there are null values now. So null values are only in embarked now. Rest of the column, there are no null values. So train.drop in place is equals to true. So we are dropping the null value. So the line of code is train, which is our data set, dot drop NA, dropping the null value. And then in place is equals to true. That is, we are going to drop the null values permanently. Okay, let's check the null values again. So we can see that there are no more null values and all the null values have been addressed. Okay, now check the data set. Now we have the passenger class, sex, age. The problem of the null value, which was in the column age and embarked, is solved. Now it's time to deal with the data which has the categorical features, that is sex column. This is the categorical feature, and embarked is the categorical feature. So what we will do, we will creating the dummy variable for those categorical feature, and we will drop the first column to avoid multicollinearity. So in the section of data pre-processing, we have learned in detail that after creating the dummy variables, why we drop the first column. So we drop the first column in order to avoid the redundant feature from the dataset, that is in order to avoid the multicollinearity. Okay, so I am creating the dummy variable for the column or the feature sex, and I am dropping the first dummy variable. That's why I write drop underscore first is equals to true. Similarly, I am creating the dummy variable for the embark dataset, and I am calling it sex for the sex sex categorical feature, and for embarked feature I am calling it as embark. Let's run the cell to create the dummy variable, and here I am adding the dummy variable to my original data. That is, I am concatenating them along the column, and I am using the command pd.concat. That is, this is the concatenation function present in pandas. Let's run this cell, and now we can see that these categorical values, that is male and Q and S, that is Queenstown and Southampton, these are appear in our data set. Now, since we have already created the dummy variable for the column sex and embarked, it's time to remove these columns because their representative are present in the form of dummy variable in the dataset. So we are going to drop the column sex and embark, and we are going to make it a permanent change on our dataset. That is, we want to drop them permanently. Let's drop them and see the dataset again. Now we can see that our dataset is cleaned now. All the issues have been addressed. That is the issue of categorical feature and the issue of missing values. Okay, now it's time to extract the features and labels so that we can apply KNN classifier on this dataset. So other than the survived column, all the other columns are our features. Therefore, if we drop the survived column, then rest of the features are our features. So let's click on this to extract the value of X, and survived column is our label. Basically, it is our target variable. Let's run this cell to extract the value of Y as well. So we have X, we have feature matrix now, and we have Y. It's time to perform train test split. For train test split, I am using a test size of 0.2. 0.2 mean I am going to use 20% of our data as a test and remaining 80% of the data as a training. Let's run this cell to split our data, and we can also check the shape of our test. So 178 samples will be used for the testing purpose. Now it's time to standardize the data. For data standardization, we are importing standard scalar from sklearn.preprocessing. And here I am instantiating my standard scalar. And here I am transforming my training data. That is, I am standardize my training data. And here I am standardize my testing data. Let's run this cell to get the standardized data. Now, before applying KNN classifier, it's time to find the optimal value of a K. We know from the previous projects that there are two methods in order to find the optimal value of K. Either we use error rate plot or we can use grid search cross validation. So here I am using the error rate. So the first step is to create the empty list of the error rate. Here I am passing the 50 different value for the K. Here I am instantiating my model, and I'm passing a nearest neighbor is equals to I. That is, when I will run this loop, the first value will be 1, then 2, then 3, then 4. It means I am calculating these values for 50 different value of K, and I will select the best value of K. And we know from the previous projects, the best value of K is that value for which the error rate will be minimum. Here I am fitting my KNN optimal to the training component of the data. Here I am getting the predictions from the testing component of our data, and here I am calculating the accuracy. And we know that the error rate is 1 minus accuracy. Here I am calculate the error rate value, and here I am appending the error rate value to my error rate list, which is here. Okay, let's run this cell to calculate the 50 value of the error rate, and here I am going to plot my error rate. So we can see that this is the plot of error rate. Let me reduce the size of this 8 by 7. I think it will be good. Okay, so we can see that this is our error rate plot. We can see that it starts from a very high value of the error, and on x-axis, if we increase the number of nearest neighbor, that is the value of K, it is decreasing. And then it is slowly and slowly decreasing, and it reached to the minimum value for the first time at this point. So at this point, K is equals to 14. So K is equals to 14 is the value of K where we get the minimum error rate for the first time. We also get the minimum value somewhere here, but first value is 14. The value of K is 14, for which we get the minimum error rate. So we select the value of K is equals to 14. So for nearest neighbor is equals to 14, I am going to instantiate my classifier. Here I am fitting my classifier on the training component of the data. That is, I am training my model on the training component. And here I am getting the prediction from the testing component of the data. Let's run this cell to train the model and to get the predictions. Here I am calculating the accuracy by comparing the prediction of the model with the original test labels. Let's see the accuracy. So we can see that we have the accuracy of 82% approximately. slightly above than 82%. Now, if we compare the performance of this classifier with the performance of logistic regression on the Titanic dataset, we remembered that in logistic regression section, we obtain the accuracy of around 77%. So here we get around 5% more accuracy than the logistic regression classifier. Okay, let's create the confusion matrix. So these are the font of the confusion matrix that I want the font size to be 15 and I want the font to be bold. So let's run this cell. Okay, so here I am importing a confusion matrix, F1 score, precision, recall value, accuracy, confusion matrix. I do not need a ROC curve here. Okay, so I can remove it. So let's run this cell to import confusion matrix, F1 score, precision score, recall, accuracy, and confusion matrix display. Okay, let's run this cell. Now it's time. So this is the repetition here, I guess. So we need to remove it. Yes. Okay, so we have already import. Now it's time to get the confusion matrix. And after getting the confusion matrix, we need to display the confusion matrix. So this will be the size of the confusion matrix. So this is very standard stuff. We have seen this code many times before, that how to display the confusion matrix. Let's run this cell to display the confusion matrix, and we can see that this is our true negative value, this is our true positive value, this is our false positive value, and this is our false negative value. So these are those values along the diagonal which are correctly classified by our classifier, and these are the errors or the misclassified values. So now we can also calculate the accuracy, precision, recall, and F1 score. So there is a typo, we can remove it here. Okay, now accuracy, precision, recall, and F1 score. So this is again the same line of code which we have seen many times now in this course. Let's run this cell. To calculate the accuracy, we can see that our accuracy is 82%, our precision is 81%, our recall is 80.5%, and our F1 score is also approximately equals to 81%. So we have seen that on this challenging data where we had a lot of features like categorical features, features in the form of integers, and there were also irrelevant features present in the original form of data, our KNN has done a great job by getting the accuracy of 82%, which is higher than the logistic regression classifier. So I hope you understood this project. Thanks for listening, and I will see you in the next lecture.